This podcast includes formulas of ionic compounds that have polyatomic ions. So a polyatomic ion is a group of nonmetal atoms that are held together with covalent bonds, and they all share one charge and together. So in formulas with polyatomic ions, if there's more than one ion, you have to put it in parentheses followed by the subscript. Otherwise, the formula will get really confusing. So let's do some examples. Magnesium nitrate. Magnesium is the same old magnesium, group 2A, and it's going to have a charge of +2. Nitrate is a polyatomic, so we're going to find it on our chart here. Nitrate is here, nitrate. It is NO3 minus. So it's NO3 together. These atoms are stuck together and they share a charge of -1. We're going to treat them like they're just one particle because they act like they're just one. They do act like they're just one particle. So that's NO3. The rest of the formula is the same pattern as always. So we've got +2 in magnesium, -1 on our nitrate. Crisscross or add up the ions to make a formula. I'm going to need 2 nitrate groups to balance out 1 magnesium. And because nitrate is polyatomic, I have to put it in parentheses followed by the 2. The 3 on the oxygen is part of my polyatomic, so they have to stick together. The 2 is on the outside. And it's called magnesium nitrate. The name of the ion is just the name that's in this chart here. Okay, sodium carbonate. So sodium is the same sodium +1. Carbonate is a polyatomic, CO3, and it has a -2. So we can see carbonate over here, carbonate, CO3, that's the group together. Those always stay together, and they have a charge of -2. So here, because the charge is -2 and sodium is +1, I'm going to need 2 sodiums to balance out 1 carbonate. So it's Na2CO3. Again, think of CO3 as one group together. Okay, ammonium sulfate. Ammonium is a little bit unusual. It is the only polyatomic cation. So if we look up here, ammonium, we also have hydronium, but we actually will never use that one. So ammonium is here. We use this a lot. It's NH4 and it has a +1. So this is our special case. Every ionic compound has a metal except the ones with ammonium, because they're cations, they are ionic, but ammonium is not a metal, but it acts like a metal. So we treat it like a metal. So NH4, which has a +1, sulfate has a -2. So to balance out and make 0, we're going to need 2 ammonium groups for every 1 sulfate. So it's NH4, group it together, put it in parentheses, followed by the 2, and then the sulfate group. There's just one of these. So again, if a polyatomic, if there's more than one group, you have to put it in parentheses, followed by the subscript of however many groups there are. So for practice, go through, use your chart, figure out what the ions are, figure out their charges, put them together, make a formula. Shut off the video, go through and try it yourself, and then turn it back on to check your answers. Okay, so on this key, I did not list the individual ions before I put them together to make a formula, but you definitely might want to do that. Don't feel like you have to do it all in one step. So here the formulas are given, and you are going to go from the formula to the name. So find the group on your chart so that you know what it's called if you don't know the name. For the midterm, we're going to memorize the most common 10 polyatomics, but for now, go ahead and use your chart. CO is cobalt, which is a transition metal, so all the old rules for transition metals, you still have to follow those too. Go through and then check your answers. Okay, if you have any questions, please see your teacher.